Alright, so we're going to use that formula. This is my x1, y1, x2, y2, x3, y3. So it's the distance of x1 minus x3 squared plus y1, which is 0, minus y3, which is 0, squared plus x2, which is 10, minus x3, which is 5 squared, plus y2, which is 0, minus y3 squared. Alright, so this is negative 18 squared plus 5 squared. So that essentially is 18 plus 5, which is 23. Same thing, x1, y1, x2, y2, x3, y3. So we're going to go ahead and use the formula again. So it is x1, which is 0, minus x3, which is 0 squared, plus y1, which is negative 17, minus negative 15 squared, plus x2, which is 0, minus x3 squared, plus y2, which is 17, minus y3 squared. Alright, so this is going to be negative 2 squared, plus this is going to be 22 squared. So that's 2 plus 20, which is 24. Alright, so for this we're going to use this is going to be my A, this is my B, and I know that this is horizontal because the vertex is on the x-axis. So it's x squared over A squared, which is 80, minus y squared over 49 equals 1. Alright, so because this is my vertex is on the y-axis, we're going to go ahead and use a vertical form of it. So it's y squared over 100 minus x squared over 64 equals 1. Alright, for this guy we have to find our B. We know this is horizontal. This is my A. So it's going to be c squared equals a squared plus b squared. So 13 squared equals 5 squared plus b squared. So 169 minus 25 equals b squared. B squared is going to be 144. So this is going to be y squared over 25 minus x squared over 144 equals 1. Alright, so let's graph. Notice that there's no number with x or y, so our center is going to be at 0, 0. This is going to be a horizontal because the a squared's underneath of my x, where my x squared comes first. So my vertices are going to be at 7, 0 and negative 7, 0. My co-vertices are going to be at 0, 6 and 0, negative 6. My asymptote is going to be at y minus 0 equals plus or minus b, which is 6 over a, which is 7, times x minus 0. So that's y equals plus or minus 6 over 7. All right, we can plot these vertices. So 7, 0, 1, 2, 3, 4, 5, 6. Negative 7 zeros here. 7's here, 0, 6, 1, 2, 3, 4, 0, negative 6, 1, 2, 3, 4, 5. Let's use our asymptote. So we're going to start at 0, 0. We're going to count up 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So this is one asymptote. My other asymptote's going to be the other way. 1, 2, 3, 4, 5, 6, 7. This is my next asymptote. So we're going to go ahead and these are my branches. Alright, so y plus 5. So this is going to be the square root of x squared plus y minus 3 squared equals the square root of y plus 5 squared. So this is going to be x squared. I'm going to FOIL that. Y squared minus 6y plus 9 equals y squared plus 10y plus 25. So we have y squareds on both sides, so those cancel. I'm going to go ahead and add this 6y. So now I have x squared plus 9 equals 16y plus 25. We're going to minus 9. So I have x squared equals 16y plus 16 divided by 16. So 1/16 x squared equals y plus 1. Alright, so this time this is my x1, my y1, this is my x2, and I'm missing y2. So let's use the distance formula. It's the square root of x plus 2 squared plus y plus 0 squared equals the square root of x minus 8 squared plus y minus y squared. So this is x plus 2 squared plus y squared equals square root of x minus 8 squared. FOIL that, we get x squared plus 4x plus 4 plus y squared equals, FOIL this, x squared minus 16x plus 64. X squared's the same on both sides, so that cancels. I'm going to go ahead and minus this 4x and minus this 4. So now I'm at y squared equals negative 20x plus 60. And we're going to divide this by negative 20. So 1 over equals positive x minus 3. Alright, write the equation of each Blaubert vertex 0, 0. Now this is horizontal because the directrix is on the y-axis. So let's find out what 4p is. 4 times 1.25 is 5. So my final answer is... So our final answer is y equals 1 over 5x. Alright, so for our next one, this is definitely a vertical. This is my p. So x equals... Alright, so that's going to equal 1 over 4 times 1 y squared. So that's 1/4 y squared. Alright, so the next one I believe we're graphing. So my center for this guy, my center is at 2, negative 1. 4p equals 2. So we divide negative 2. So we divide by 4. P equals negative 1/2. So therefore p is less than 0, so it opens to the left. My foci are going to be, my foci is going to be at 2 plus negative 1/2 comma negative 1. So that's 1.5 comma negative 1. And then my directrix is x equals h minus p. So x equals 2 minus negative 1/2. X equals 2.5. So if we graph that, let's graph my 2.5 directrix. My center is at 2, negative 1. Alright, so number 15, let's start with our center. Our center is going to be at 0, comma 4. Let's find 1 over 4p equals 1 over 24. So 4p equals 24. P equals 6. So it's greater than 0. So we're opening to the right. My focus is going to be h, which is 0, plus my p comma k, which is 4. So that's going to be at 6, 4. And my directrix is, remember, x equals h minus p. X equals 0 minus 6, negative 6. So let's go to negative 6. 1, 2, 3, 4, 5, 6. My directrix, my center is located at 6, 0, 4. Alright, last one. Alright, so my center here is at 2 comma negative 1. 1 over 16 equals 1 over 4p, so 4p equals 16, p equals 16. So this is going to open up. My foci are 2 comma negative 1 plus 4, which is 2 comma 3. And then my directrix is y equals k minus p. Y equals negative 1 minus 4. Y equals negative 5. 1, 2, 3, 4, 5. My center is at 2, negative 1. Alright, so for 17, the cross-section of a larger part can be modeled by the equation. What is the length of the feed horn? Well, the feed horn is the distance to the foci. So basically, all we have to do here is 4p equals 132. We divide by 4, p is 33 inches.